All right, so this is Justin Dill with Truckers Weather. Tonight I have the honor of interviewing Tim Marshall. He is a renowned engineer and meteorologist out of Texas. Tim, how are you doing this evening?
Doing great. It's a bit hot here, though.
Yes, sir. That Texas weather always cooks you out there. So, for our new viewers here that may not know who you are, can you introduce yourself and give us a background of what you do and how you're involved in meteorology and engineering?
Yes, my real job is as a forensic engineer and meteorologist with Hague Engineering in Dallas, and that's someone who goes out and surveys damage and determines the extent of damage, how much maybe it'll cost. That's some of the things I do.
Okay.
Then my hobby is to chase storms, hail, lightning, tornadoes, hurricanes. I've been doing all that for since the late 70s.
In your background, studied under Dr. Ted Fujita, and you revised the Enhanced Fujita Scale at some point ago. Can you tell me a little bit about that? How does that all work together?
Well, just to clarify, I did not study under Dr. Fujita.
Oh,
Uh, he was at the University of Chicago. I went to Northern Illinois University. Brian Smith, my friend, started there at the University of Chicago, or actually ended up there. So I was in the Chicago area as a child, and we had a tornado come through our community and damage lots of houses about a mile from me. And I was very interested then in the weather. And then, in particular, that event struck my interest on tornadoes. And I said, man, what is this thing that comes out of the sky? It's nothing more than air and water vapor.
right.
And air and water vapor, pretty light stuff. How does that do that? My parents had no idea about tornadoes and how they form, so they asked me to go to the library, and I did. And I really didn't find a whole lot there. It was mostly popular books. So I wrote Fujita, and he sent me a bunch of maps and some information. I wrote all the three TV meteorologists, or really weather people, not really meteorologists. Then they sent me a lot of popular stuff. So it wasn't until really in high school that I was able to find more technical journals and things that talked about tornadoes and really how they form. And I really was interested in that. And in my high school, they had a weather club that was formed in my senior year, and that was fantastic. I got to meet several people who were just like me and had the interest of weather. And then it was on to college, and I did 9 years in college, getting a bachelor's in meteorology, a master's in atmospheric science, and a master's in civil engineering. So then I got a job, and it's been one and done with the job. I got a job at Hague in Dallas, and it's been a great run, and I've spent my whole career surveying damage.
That sounds like a lot of fun. Hague Engineering, is that basically like the same people that do like National Weather Service surveys after a storm is done, or is that its own entity, or how does that operate?
Hague is its own entity. We do a lot of work with insurance people to evaluate damages. So what I do with the Weather Service is outside of Hague. It's a voluntary thing where they will call me in, or I will be there, and then they'll find out about it because I'll let them know, and they'll ask me for my opinion. It's still ongoing. I get asked quite a bit about certain tornadoes that happen, and so I've been more than happy to give them another opinion on the matter anyways.
All right, guys, this is Justin Dill and Tim Marshall here talking about the 2024 and 2025 tornado research. Tim, again, glad to have you on the show. What tornado events from 2024 and 2025 stand out most in your recent damage surveys, and any surprises on intensity or storm patterns?
Well, earlier this spring there were some violent tornadoes that hit northern Arkansas, and I happened to be in Little Rock at the time doing an assignment for Hague, and I had a couple extra days. I said, okay, I'll run up there and look at the damage. I notified the folks over at Memphis Weather Service I was going to be there, and they gave me particular points they wanted me to look at to say, okay, and also Little Rock. Little Rock was involved with this. So there were tornadoes that, of course, went through northern uh, Arkansas into Missouri. And so I went out and I hunted down these specific points they wanted me to look at. There was quite intense damage. There were three very strong tornadoes that went long track through northern Arkansas and did you know, EF3, EF4 damages. So I looked at those spots and determined the quality of construction and what wind it would take to knock these houses down.
Oh, wow. All right, Tim, in your field of work, did you observe any anomalies that challenge current understanding of the Enhanced Fujita Scale?
Well, the Enhanced Fujita Scale is a subjective scale from 0 to 5. So it's based on increasing levels of damage, 0 being the least damage and 5 being catastrophic damage. So it's up to really the resistance of the building to determine what kind of wind speed we're talking about here. So houses that aren't built very well fall down at low wind speeds, whereas steel reinforced concrete buildings are usually engineered. It takes a really strong wind to do serious damages to those buildings as far as structure. So it's an increasing scale, it's subjective. There's nothing really too rocket science about it, but it does get controversial at times, especially when you're talking about is it a 4 or is it a 5?
Right. So for people that don't know, they might still be stuck on the old F scale. What is the difference between the F scale and the Enhanced Fujita? And are there possibly any changes to, like some people might ask, is there ever going to be an EF6?
All right, as far as EF6, no, there'll never be an EF6. EF5, as far as the damage indicators, there's only a handful of damage indicators at EF5 even. And for EF6 to happen, if it were to happen, it would be like a high-rise building collapsing, which we have not seen.
Right.
So I don't think that's going to be happening. The Enhanced Fujita Scale and Fujita Scale are still 0 to 5, but the EF scale has lower wind speeds because we found from engineering surveys that it doesn't take 300 mile an hour wind to completely destroy a house. A 200 mile an hour wind can do that.
Has there been anything in significance to ever, one of two questions here is like, has there ever been a high-rise building to be catastrophically, demolished or destroyed by a large tornado? That's
No.
the first question.
But there has been the Great Plains Life Building in Lubbock, which is a 12-story building that's wrenched out of plumb about a foot up at the top level.
Hmm. And the other part of that question is like, say you got the new building over in Oklahoma City, like if a large tornado were to come through a major population, say St. Louis or Oklahoma City or whatever, are these skyrise buildings strong enough to take a EF3, 4, or 5?
Yes, they are designed so that if the exterior of the building gets overloaded, it'll blow through the building. So it'll save the structural frame. And we've seen this happen a few times where high rises have been hit by very strong tornadoes. It just blows through. So a lot of these buildings, of course, don't have much inside. They have some cubicles maybe, but the best place to be would be in an interior hallway or better yet, bathroom that's in the interior.
Okay, but since we're talking about high-rise buildings, is an elevator okay to be in as far as a safe area during a tornado warning? Like if it's coming at you, would you still say a bathroom would still be the best bet? Or a cubicle under the desk? Where would be a safe space for an office worker in that situation?
Well, it's all about the timing. First of all, don't get in the elevator. Second of all, if you got time, get to the interior of the building, especially if there's a bathroom in there. That would be your best bet. Being under a desk, under a cubicle, not a very good place to be, especially because a lot of these buildings today have a lot of glass facades. So they're totally glass or a combination of glass and stone. You just don't want to be anywhere where glass is flying around. Because as you know, glass flying around about 100 miles an hour, that'll go right through flesh, no problem.
Okay. All right, so we already answered that question here. All right, next question is how did the scale and frequency of tornadoes in 2024 compare to historical averages? For example, record activity in Oklahoma or Florida or any other location.
I haven't looked at the current stats with it, but I would say it varies from year to year depending on your state and your location. Sometimes parts of your state do not get very many tornadoes on some years, whereas other years it does. For the most part, overall, there's this general maximum in the plain states and in the southeast, and that seems to hold true over time. So there may be regional variations based on the season or the year, but overall, the maximum occurs in the center of the U.S., Midwest, and Southeast.
Okay. All right. What structural damage trends did you identify in recent EF4 storms like the Barnesdale, Bartlesville, and Greenfield outbreaks?
I think are you talking about Iowa? Are you talking about Arkansas?
Barnesdale, Bartlesville, Oklahoma, and Greenfield. Yeah.
Yeah. The buildings that were hit are mostly residences, and they're older buildings, so they're usually on a perimeter foundation. They have a floor platform. So the weak link is where the wall studs are tied into that floor platform. It's usually a straight nail connection. And that's where the failure normally happens. And it doesn't take a 4 or 5 to do that. It can be knocked down pretty much with 2 or 3. So it's tough to rate these any higher than that when you don't have a whole lot of damage indicators.
I misread that question actually with the city name. I apologize. That's a blooper on me. All right. Next question is, can you discuss any novel findings on tornado wind field dynamics? For example, Doppler measurements exceeding EF scale estimates.
Well, Doppler radar's measurements is not really of wind. It's of the particles that are moving in the wind, and then it's only along a radial, which is to and from the radar. And it's an instantaneous number, but it's weighted over a volume. So we really don't have a point measurement with a radar. And we don't have the same type of wind on the baseline as we do with the EF scale. Now, the EF scale is based on the wind speed that's a 3-second gust. That's a time average at 10 meters or 33 feet above the ground. So that's the baseline. Doppler is totally different. Doppler is instantaneous. It's not at 10 meters above the ground. And certainly it's an average over some volume, but we can't really get to a point. And to date, there's no equation that you can say, all right, your Doppler wind was this, and so forth, you correct down to this for the EF wind. And there's been some studies done on that, but it's all over the place in terms of what that equation might be. There's no really consistent, like a power law or something that we could use to extrapolate that on down. So it's kind of apples and oranges when it comes down to Doppler wind, and then you got the actual EF scale wind. And that's when the real controversy, because Doppler can get winds over 300 miles an hour. We've seen it, and it's like, well, is that an EF scale number? No, it's not. And so that's where the confusion arises and the controversy arises, is that they are two different winds.
Gotcha. I've always wondered how that worked, actually, me personally. How have advancements in mobile Doppler radar and drone development improved your post-storm assessments? How has that helped you with your research?
Oh, the drones that are done today, and I've used some, revolutionized damage survey. They are absolutely spectacular. We've taken drones out, and we can get up to areas that we can't see, like the roof wall connections. You got a 2-story building. I don't have a long ladder, at least usually with me. So and they can do it quicker. They can do it faster in terms of zooming around the building and get more detail than we can. And we'd be spending an hour there, and the drone could do it in 5 or 10 minutes. So it's really been helpful, a time saver, and much more detail. And we really like. I think it's an essential part of actually doing any damage surveys, having a drone.
Okay. Have you encountered damage in 2024 or 25 that suggests current civil engineering standards are inadequate?
Well, civil engineering standards, we're talking about the wind standard. The wind standards don't design for tornadoes and for the most of the buildings that we live and work in. So really, the building code is a minimum criteria that's ranges between 90 and 150 miles an hour, depending upon which state you live and where you're at in the state. And that's really all the buildings are designed for. Usually engineered buildings are higher and they're more detailed. The standards, at least right now, they're working on a standard about tornado design, and that's going to be great for more hardened buildings, but not for the common buildings that we all live and work in.
Okay. What role do mesoscale atmospheric features play in the formation of violent tornadoes based on recent outbreaks?
Well, that's a loaded question, I'll tell you, because the what goes into making a tornado is really room for debate, and there's a lot of things we still don't know, and that's why we are doing these field projects to try to find out more and more. Certainly, we've learned a lot over the decades that I've been around. When I asked my parents how tornadoes form, they say, well, our best guess is if you see lightning going in a circle, that means the tornado is going to form. Well, we've come a long way from that, okay? We really have. We have got beautiful illustrations now that show, and numerical modeling that has shown that the supercell tornado really evolves out of the rotation of the updraft and its interface with the downdrafts, and it kind of squeezing that updraft and causing this vortex to form and stretches it, and it's very important. And so that's pretty much what a lot of those supercell tornadoes are. And of course, then we have the QLCS tornadoes, which are kind of line segment tornadoes, and they form when different parts of the downdrafts kind of surge out and wrap up in an updraft at the leading edge, and they're very quick to form, and we get a lot of quick tornadoes with that. So there's a couple different mechanisms for tornado formation. We're learning more all the time, and the field still needs meteorologists out there observing, taking measurements to help us better understand tornado genesis.
Okay. Yeah, that's definitely a loaded question. How has climate variability or warming influenced severe weather patterns in your recent research?
Well, of course, climate variability is a long-term thing, whereas the research that we do is a very short-term thing. So we really can't draw any definitive conclusions either way. We can make some inferences, we can make some guesses, and we can say that a warming planet means more water vapor, and that could mean more storms. Mm-hmm. So the odds are we could increase on tornadoes. And also another factor is the population is getting bigger, the cities are growing, the targets are getting bigger, so the odds of having a violent tornado hitting an area where people are is growing. So that's also adding that effect. So I think what we're looking at here is a future where we have to have better warnings and better shelters for people so that we don't have hundreds of people dying in a tornado outbreak.
Agreed. Okay. How has climate... Actually, I already answered that question. Have you begun applying any AI or ML tools such as TorNet radar data sheets or tornado detection in your damage analysis?
I have not yet. I do see a future in AI in meteorology, especially when we're talking about forecasting, when we're talking about modeling tornado dynamics. AI is going to be a big player, I think, in the future here. But right now, for my damage survey work, I really don't have it involved and employed it. And one of these days, I'm sure I'll see that its importance, and then we'll incorporate it as necessary.
Okay. Have you collaborated with any academic groups in 2024 on extreme tornado documentation, perhaps in the United States or in Canada or any other country?
Well, right now we have the EF Scale Committee, and we're working with the American Society of Civil Engineers, the American Meteorologists Society, and the Structural Engineers Institute in developing what's going to be a tornado wind standard. And this tornado wind standard will actually have a lot of the things we're talking about in it, including really how to apply the updated version of the EF scale. So it'll be a very big, thick document. I'm estimating about 500 pages.
Mm.
But it's been a work that's taken a long, long time because we have a lot of people involved in this committee, and they all have their say. And so we have to address what everybody says. And that's been a lot longer task than I ever thought. But I'm hoping before I go senile that I can have this publication in my hand and say, hey, here we go. We've got a tornado wind standard here, which incorporates a lot of the variability that we see out there in our surveys, and we'll have a better understanding of these damage indicators and what wind speeds it takes to cause what damage.
Okay, sounds pretty cool. In regions like Florida or New York that experience record tornado counts, did damage reflect unexpected structural vulnerabilities?
Well, these areas that are, New York and northern Michigan, Maine, they can get tornadoes and have. I was in Pennsylvania a few weeks ago, and everybody still remembers the big outbreak in '85 up there. So it's like, these outbreaks don't occur very frequently there, but they do occur. And tornadoes occur in Canada, especially in the western part, but they also occur in the eastern part. So it's like, it may be a long time between big outbreaks, but they do happen up there, and those buildings need to have some resistance to that. Unfortunately, they don't a lot of times and end up having catastrophic damage.
Okay. Tim, have you noticed changes in population awareness or infrastructure resilience following recent tornado events?
No, not really. We build them like we built them all along. There's been some, some minor improvements along the way. Certainly, Moore, Oklahoma had increased their building code, and that was a good thing. The state of Florida has their own building code, and that's a good thing. But for the most part, the rest of the country, you're pretty much on your own. You build it how Grandpa built it, and so there's really not much in the way of tornado resistance. The houses are not normally built to resist tornadoes.
Okay, I got a question from last year when you and I had talked. You told me last year that your local fire department, you needed to register if you had a tornado shelter with that fire department, right? Do you see that becoming more of a thing that should be more normalized along smaller populations or within other fire department agencies? Is that something that should be pushed into law or something similar?
Well, I don't know if it should be pushed into law, but certainly if you have an in-ground tornado shelter, even above ground, you need to let other people know so they come to find you afterwards. Problems we've seen is that either with above ground or below ground, debris gets piled up on the door and they can't get out. You're trapped inside the shelter.
Mm-hmm.
And Some of the newer requirements on shelters actually have a second escape hatch, which is really great to have. But you never know when all that stuff gets piled up in debris, and you just need to have somebody come and get you. A lot of times, cell service doesn't work afterwards, so you can't call. It's always a good thing though to bring your cell phone into a shelter or have a cell phone handy so people can find you. But really, registering is a good idea.
Okay. All right, we're going to go on toward another category, and this is going to be under a wider role as a meteorologist and researcher and engineer. Do you need to take a quick break and grab a drink or something?
No, I'm fine.
Okay. All right, continuing on. Tim, how did your background as a structural and forensic engineer influence your interpretation of 2024 tornado damage?
Well, engineering is an important part of this damage survey business. In engineering, I learned how buildings were put together and I learned how they fall apart. And that's a critical component when you're out there doing a damage survey. And we're trying to teach as much of that to the meteorologists who do surveys so they have a better understanding to look for those critical connections, what I call the fatal flaws in a building. So the roof wall attachment is one, and the wall floor or wall foundation attachment is another. Those are very critical types of connections that need to be looked at in many buildings, many building sites, not just residences. So it's all about how it's all put together. And once you learn how it's supposed to be, and then you're out there looking at the damage, then you have a better understanding about it's not just a jumble of debris. You go out there, you look at it and go, oh, okay, there's a bond beam over there that was on top of a masonry wall. Let's see if there was any kind of connection between that bond beam and the rafters. I mean, you are able to pick it apart when you go out there and see a pile of debris. It's not just a mess. You know about the various components to look for.
Okay. What gaps do you see between real-world damage evidence and numerical tornado models?
Well, numerical models are an approximation, right? So they have to make various assumptions. And those assumptions then they test with the real world. And they tweak it accordingly. So it's always a challenge. Numerical modeling has definitely gotten a whole lot better since I was a grad student. And see what's being done is just awesome. I attend these SLS meetings over in various parts of the country, which are severe local storms meetings. And it's amazing to see what the students are doing with numerical modeling. So I'm all for it. It's just an approximation, but we're learning a lot more about the tornado because here, when we're talking about trying to measure winds in a tornado, we really can't do much of that with the equipment because the equipment we use is not hardened for that. So a piece of debris comes about and it knocks your anemometer off or destroys it. You don't know what it would have measured. So numerical modeling fills the gaps in our science.
Sounds good. Actually, that dances with this next question here. How have storm chasing technologies such as drones, pods, or radar-equipped vehicles evolved since you started, and where do you see them headed towards next?
Sure. I mean, look at what's radar. I mean, radar was a fixed position when I started out. And then Josh Werman, Howie Bluestein, they all decided to put radars on the truck. Well, that's insane because it involves a lot of electronics and bouncing around in a vehicle. Certainly something's going to go wrong. And it took years for them to perfect this and get it down to the point where now, they still have problems now, but now they have tremendous range and are able to get very good data, very detailed data. It's really been amazing to see such a kind of these micro features in tornadoes that we had never seen before.
Okay. Got a couple bonus questions for you here. What is your perspective on these? What insights did you gain from your experience chasing the Sulphur, Oklahoma wedge tornado or other high-profile storms?
Well, certainly it's one of the closest I've ever gotten to a tornado. We deployed a pod there, and it got in the circulation. It didn't get in the core, but it got into circulation. We had about 100-mile-an-hour winds in it. It did break the anemometer, unfortunately. There's a lot of flying gravel that pitted the entire mast that we had. It was a painted mast that completely peeled the paint right off. It was really a good thing because we were able to take that data and compare it with what the Doppler radar was saying. So we were able to do some correlation. And that's really what was important, was to try to see, well, if the radar is saying instantaneous, kind of averaging, and we have point measurements, then we can compare the two and get a better idea. What is the relationship between the Doppler winds and what we're measuring?
Okay. All right. The next question is, can you describe your ongoing work with HAG Engineering and the National Weather Service on damage scale refinement?
Well, currently I am on what they call an emeritus program, where I'm trying to retire. So I'm one step from retirement. I just have to do it, and it's a big step though. So I'm going to stay with Hague for a little while longer, and then I'll retire at the appropriate time. And again, that's most of what I'm doing right now is mostly legal work rather than field work. That obviously days like today where heat and humidity, there's no way I'm going to be able to survive outside in this environment. So I'm going to work with Hague for a little while longer. As far as consulting with the National Weather Service or doing damage surveys, that's outside of Hague, of course, and I'm going to continue to do that. I find it fun to do. I'm going to continue with the ASCE Tornado Wind Estimation Committee and try to be helpful with them to try to finish that project. So hopefully we can finish it in the next couple of years and have it published.
That sounds like a lot of fun.
Yeah.
How has storm chasing shifted from chasing as a hobby to a vital scientific endeavor over your career?
Well, mostly it is a hobby for me, and I like to go out and see a storm and photograph it. But I have gone on six field projects. 5 were for tornadoes, and this last one here was for hail. So
I want to hear about this one. Yes.
Yeah. I want to get back to science. There's plenty of people out there taking pictures of tornadoes, and it's it becomes kind of mundane after a while. Although I do like to see tornadoes because they're all kind of different in their shapes and sizes and how they behave. But it's getting to be a to-do out there with all these people, and so I like to get back to science and see, can we do something more than just take pretty pictures. Mm-hmm. So that's why I've gone out and worked with Josh and Karen in deploying pods in front of tornadoes for 5 years, and then this latest endeavor was with Northern Illinois University and Dr. Victor Gensini in trying to get into hail cores and sampling hail, again correlating between what radar is seeing and what we're seeing on the ground as far as hail, and doing a lot of testing on hail. So yeah, this year they asked me to be part of it. Although I'm an old guy, I'm still game for doing more science, and so I was with a bunch of graduate students who I had a great time with, and we went out and we got in hail core after hail core. It was amazing.
I remember some of the pictures you posted on Facebook, and some of them were just amazingly huge. Like, I could not believe the size of those hailstones that you were able to measure out with your tool that was doing the measuring. I was like, man, that stuff is coming out of our atmosphere. What's the largest one you found? And tell me about some of that.
Yeah, we encountered many hailstones over 5 inches. That's
wow.
Our largest one was 5.9 inches. Was near Menard, Texas. It was right on the west edge of Menard, and the big hail was falling far apart. We only got hit twice on the vehicle, and we had a shield over the vehicle so that we could protect our windshield. We didn't lose the windshield at all during the entire campaign, which is a testament to the engineers who designed that shield for us. That was great.
Sounds like a good episode of The Next Generation with your shields up, man.
Absolutely. It was great. we had 45 days of operations, we had 24 what they call IOPs, or operations that we were actually hunting down storms, and about 20 of those were actually where we got in hail cores. So just think of the ratio. That was pretty good. This whole season was, from beginning to end, was extremely active, not only for tornadoes but for hail. So we got into hailstorms like every other day. We were in hail, and it was amazing that the vehicle survived, and we survived, and we absolutely over 10,000 hailstones were measured here with this project. So
that's a lot.
Quite an achievement. Yeah, that's going to advance hail science tremendously for years to come.
What is the focus on the hail science? What's the point of them doing the science behind the measurements? Like, what are they hoping to accomplish with the research? Like, what's the goal?
Well, there's many different goals here with this project. This goal is multifaceted. In my arena, we were collecting hail to measure and document the sizes of them. Then the big stones would be shipped off to a lab at NCAR in Boulder, Colorado, for more detailed analysis. What they would do is they would cut through them, and they could go through those layers and tell how many times did it go up and down in the storm,
in the
and
updraft.
where it
Wow.
was, and do all that. And that's just what we were doing. There's so many other aspects. There's distrometers that were set out there to measure sizes, and of course, I talked about the radars already. The radars could see something, and they come off with a reflectivity measurement, and we could correlate that within the hail size.
What is the best tool on the radar to measure hail? Is it the EchoTop, the VIL, or just standard combined reflectivity? What would you suggest for anyone that's wanting to track hail per se? What's the best
for hail,
tool?
there's multiple modes here that you're talking about. I mean, reflectivity is only one.
Mm-hmm.
All right. So you have a differential phase, which is the different phase transitions between ice and water. That's another thing. You have certain types of correlation coefficients can be helpful too. So all the modes of radar have limited uses, but some more than others. But the KDP, the differential phase, was one of my favorites.
I'd love to check that out some more. That sounds really good. All right. Let's see. All right, back to what we were talking about home building and whatnot. What are the biggest engineering challenges today in constructing tornado-resilient homes and public structures?
It's a couple things: the money and convincing that it's people that it's a worthwhile thing.
Okay. And could you summarize any key takeaways from your 2024-2025 2025 keynote at the Southeastern Coastal and Atmospheric Processes Symposium?
So, which one was this now?
The Southeastern Coastal and Atmospheric.
Oh, yeah.
Yeah.
Okay. Well, for that conference, my goal there was talking about the hurricanes along the Gulf Coast that I've experienced. So we have, a long history. My first hurricane was 1980 that I was actually in. That was Hurricane Allen. And I've been through dozens of hurricanes since. The most intense one being actually kind of a tie between Hurricane Harvey and Hurricane Laura. Those are the two most intense hurricanes I've been in. Of course, I only stick to the United States. I don't go into the Caribbean or overseas. But I've seen dozens of hurricanes up close and personal.
Okay. I'd love to talk to you some more about hurricanes at some point, for sure. The tornado-specific topics I'd like to cover real quick. The future of the EF scales, limitations, potential upgrades, and how engineering input might shape EF reversions. Are there any reversions coming?
Oh, there's tremendous revisions coming. We have a document that was 100 pages or 110 pages originally back in 2006. And now we have a document that's 500 plus pages. So we are increasing the complexity of this immensely, which means that there are going to have to be training modules developed after this is published that will have to be done so that people can learn all the new and great things that we've done over the last decade. It started in 2015, and we are still going at 10 years with this program to try to get a standard. And it's going to be quite the standard when it comes out, so we're really looking forward to it.
Okay. Some case studies of extreme tornadoes I'd like to talk about. The Moore of 1999, May 3rd, Joplin 2011, in El Reno 2013, and any other case studies that you can talk about with any of those.
Well, I've looked at, over 100 different damage surveys from tornadoes and hurricanes and floods and hail. But the ones you mentioned really are some of the tops there. So with regard to Joplin, that was really amazing tornado. It went through 6 square miles of South Joplin, and it mowed it down. I was amazed.
Was that the fastest spin up of a tornado ever recorded? That just came out of nowhere.
Well, it didn't come out of nowhere. I mean, it was the storm that it formed from was being monitored. It even had tornado warnings on it. It just turned to the right, and so everybody thought it was going to kind of go north of Joplin, but it had its own mind and decided to take a hard right and come right through the city, the southern part of the city. So where there were like 8 houses a block, it mowed them all down. It was amazing to see that the consistency of the destruction.
Now, has that one had any characteristics as far as its travel, like the El Reno when it shifted northward? I think you had mentioned last year. Like, did they share similarities?
Well, the similarity was that the tornado ramped up fast, and then it took a hard right. But with El Reno, that took a little while to get going, and it widened progressively, and then took a hard left and actually accelerated. So those two features, taking a hard left and accelerating, were unlike that of Joplin. And in fact, I have never seen a tornado do all those things simultaneously. It kind of widened, it took a hard left, and it accelerated. And that caught some chasers off guard, unfortunately. Mm-hmm. But we had to actually flee ourselves because we were also pretty close to it.
When you come close to chasing these large tornadoes, what goes through your mind about safety, number one? Like, how do you always ensure that you may have an escape route to get yourself out of that situation? What do you go through processing the analysis of the storm and keeping yourself safe? What would you say to someone that wants to do something similar but always leave themselves an out? We talk about something like this in trucking, leave yourself an out. What would you say to anyone that's chasing and stimulated, I guess you say, on this situation, chasing the storm, but not thinking about safety per se? What advice can you offer for someone that's going toward a tornado of such these sizes?
Well, of course, you want to keep your distance, and I do for the most part. If I'm going to get closer in, I would rather have my camera zoom in than me zoom in. So I'd rather do that. But again, sometimes you got to cut it close if your escape route is pretty close. So you always try to have as many escape routes as you can. And sometimes those escape routes get cut off for whatever reason. Tornado, big hail, sometimes flooding, sometimes roads are closed.
Muddy roads for sure.
Yeah, muddy roads. The GPS says it's a paved road. Well, no. It's a muddy road. So we've had all kinds of issues in storm chasing. And unfortunately, And, I have not been in a tornado. I don't want to be in a tornado. It's not my life goal because you don't live too long when you do that. So I like to keep my distance and photograph them. And it's not always 100% that way. We get close sometimes, too close. But keeping my distance. Hey, I'm still around. I've done this now for almost 50 years, and I plan on being around for several more years chasing before I retire.
You better.
Oh, yeah.
All right. Tornado myths versus reality. Common misconceptions seen in media or public reactions. What can you discuss about
there's a
that?
whole bunch of myths with tornadoes. And it just seems like once you learn from Grandpa about a tornado, you see it's hard to dispel that. So, when I was a kid, we were told if a tornado warning is issued, to open the windows, and that's not a good thing. First of all, if a tornado warning is issued, that means a tornado is sighted and it's in the area. You want to seek shelter. You don't want to be opening windows. And in fact, there's so much debris that flies around in tornadoes that those windows open by themselves anyways when they get hit with that debris. So it's really futile to go ahead and think that you're going to be able to alleviate some pressure because you're going to open a window.
Right. Should you try to outrun a tornado warning if you're in the path, like say take off in your car and try to travel out of its direction, or is it safer to stay at a sturdy home? Right. I know if you're in a trailer or something like that, you need to try to evacuate, yes. But if you're in a sturdy home, like a brick, home or something like that, is it usually safer to ride it out in your home than it is to travel and escape?
Well, it all depends on whether you live in a city or not. If you live in a city, it'd be ridiculous to try to do that. You know what rush hour traffic is like. Can you imagine everybody in their car trying to drive away? It'd be total gridlock. You certainly put in as many walls between you and the tornado as possible. Seek shelter in an interior closet or basement or someplace like a bathroom that has additional plumbing. I'd say stay at home for the most part. And if you're out in the country, different story. If you have plenty of time, you feel you can drive away from it, then do so. It's really a judgment call, and it's just the whole point is be aware. Be aware of what's going on. If a tornado is 20 minutes away, well, you have plenty of time to prepare. But if it's like 10 seconds away, well, you better have a safe place in your house that you can get to quick.
Okay. Tim, would you like to talk about hurricanes by chance?
No, we can talk a little bit, sure.
Okay. Let me get some questions for you here real quick. Hurricane and wind damage questions. Here we go. Under the category of structural damage and engineering, what common building failures do you see after major hurricanes?
Well, pretty much the same as we see after tornadoes. I mean, wherever there's a weak link, Mother Nature takes advantage of it. So, is it the roof wall connection or the wall floor connection? And we see a lot of things coming apart, like right there. That's the major structural problems.
How does hurricane wind damage differ from tornado damage in structural forensics?
Well, it's the same. I mean, we use structural forensics to go ahead and evaluate wind damage to buildings all the time. Same thing.
Okay. Are modern building codes in coastal areas sufficient for Category 4 or 5 hurricanes?
No, not really. The code that is the best code for hurricanes right now is in the state of Florida, and they do have debris impact zones specifically singled out, so people need to have shutters there or impact resistant windows, which is a good thing. But really, for the most part, 4s or 5s, you really have to go above the code, and that means you yourself have got to stipulate to the contractor that you want to go above the code, which is going to cost you, but you can do it. I mean, you can go ahead and put down, for example, for a tile. Instead of just nailing or screwing the tile at the top, you can also clip it at the bottom. You can also adhere it with an adhesive. So just that step alone can save you tiles blowing off your roof. But then your house is only as strong as your neighbor's, right?
Mm-hmm.
So if your neighbor doesn't do that, then you're going to get their tiles during the hurricane, and that's going to bust apart all your tiles. So it's like it's going to be kind of a concerted effort by a community. And there is one community I know down in Southwest Florida. They've done a lot of good things to try to harden their whole place, including burying the electrical lines so that they don't lose electric power during the hurricane, and having generators just in case, and trying to limit anything that can fly. And so having better built homes can go a long way.
Right. Okay, what lessons have you learned from damage surveys after hurricanes such as Ian or Michael or any other big ones that you like to talk about?
Well, the first and foremost lesson to be learned is know your elevation. You do not want to be in water. So that is a bad thing. So you want to make sure that you are built above the floodplain plus many feet above it in order to look at the history and see what was the highest surge there. And in some places you simply can't build. There are places along the Mississippi coast which I've seen 30-foot water lines on. So it's like you'd have to build way high, above 30 feet, almost take an elevator to your house if you want to build near the coast. And there are some places that they're doing that. There are places that they are putting homes up on these tall pilings, and they have elevators to go up to them. I saw them on Boulevard Peninsula, but those houses are way, way up there. Mm-hmm. You get a great view from up there, but certainly you have to think about getting away from the water.
We're coming up on the 20th anniversary, I believe, of Katrina. Did you survey that storm, and if so, or can you tell me a little bit about your thoughts on Katrina?
Well, I wrote out Hurricane Katrina in a parking garage in Slidell. We got the eye briefly there, and the survey afterwards, I spent about 6 months
20 years.
doing individual assessments, and then I spent about 6 years doing legal work with Katrina. In fact, I think my last case was 8 years. It was really a tremendous destruction along not only New Orleans, but along the Mississippi coast. New Orleans gets a lot of the press, but the destruction in Mississippi was just as severe, if not more. And of course, they had a lot of loss of life due to the tremendous surge that came in, because the Mississippi coast was, for the most part, on the right side of the hurricane, so they got the wind and they got the water piling up.
Right. As far as other hurricanes like that, or do you think there might be another major hurricane like Katrina to affect us in our lifetime?
Well, it depends whose lifetime you're talking about, mine or yours.
How about let's say the next 10 years. How about that?
I would say yes. In the next 10 years, I do believe there's going to be another major hurricane hitting the coast somewhere and causing billions of dollars of damage. It's just the odds are pretty high. In the next 10 years, we're going to have a big one.
As far as ice melting and that water, the ice melting and getting to the seawater, does that really intensify hurricane development? Or is that more of a folklore? Or I'm not sure of the science behind that one.
Really, the salinity of the ocean, I'm not sure has a significant role to play here, and it's not getting diluted any significance by fresh water coming into the ocean. The hurricanes certainly depend on the temperature a lot more than the salinity. The evaporation process is what they drive off of, and in the tropics, if you're having 90-degree Gulf water, then the hurricanes can really intensify. So I don't think the salinity has much to do with it. but I do think the temperature has a lot more to do with it.
Gotcha. All right, good question here. I think I found here is how important, or excuse me, how have you encountered cases where storm surge was mistaken for wind damage in claims?
All the time, yeah, that's what my specialty is.
All right, how do you determine that?
Uh, Really, when you think about it, um, wind and water act really to go ahead and opposite each other. Wind is greatest up high because wind increases above the ocean, and then water, of course, is greatest force near the bottom or where it comes into contact with land. So if you're looking at a building, uh, top down is really for wind, and then bottom up is really for water. So you see a lot of times where water will gut through the bottom of a building and leave the top of a building just intact.
Okay.
So it certainly is one thing that uh, is important to look at is, which type of damage do we have? We have a top-down damage, we have a bottom-up damage.
Gotcha. It's interesting there. I like that one. All right, on towards meteorology and forecasting. How accurately do hurricane wind fields forecasts match actual damage seen on the ground? Has hurricane forecasting gotten better as well?
Well, certainly hurricane forecasting has gotten a lot better. I mean, if you look at comparative, the cone of uncertainty, it has certainly narrowed over the years. So hurricane forecasting has gotten better with time. The only thing that hasn't really gotten much better is intensity forecasting. It's really hard to forecast the intensity of a hurricane when it makes landfall. There are so many factors that go into that, and that's really a big question mark. Sometimes hurricanes will well up warmer water, and we just talked about warmer water leads to more stronger hurricanes. So they intensify right up to landfall. Well, others somehow get cooling. Maybe it's fresh water that comes in, and they get a pocket of fresh water which is cooler. So the temperature, again, being colder, will decrease the hurricane.
Okay. Right on. What tools, such as satellite, radar, or drones, are improving post-hurricane analysis the most?
Well, the drones that we use certainly cover a lot of ground, but I actually do a lot of aerial work after a hurricane because I need to cover really a lot of ground. I mean, drones are good for a neighborhood, but I need to cover like counties. And so in order to do that, I have to go ahead and fly the path.
Gotcha. Now, can hurricane eye walls ever produce tornado-like wind signatures?
Yeah, hurricane eyes are not just a big round cylinder. There are definitely, right around the perimeter of them, there are accelerations that occur, sometimes called mesovortices there. And these are tremendous ramping up of wind that happens. And I've been involved in several of these, especially in Harvey, where all of a sudden, be nice, fairly calm in the eye. And then as you get to the edge of the eye wall, it just goes crazy for a few seconds there. And it's like pulses. So that can happen. Now, with tornadoes occurring, and the hurricane is usually in an outer band to the right of its landfall, and they're usually an individual cell. And this past year, we had tremendous tornadoes in Florida that were out ahead in Ian, I believe.
Okay. All right. Broader research topics. How has climate change affected hurricane behavior or intensity in your view?
Well, looking over the long term, hurricanes depend upon a lot of things. The warming of the water is one ingredient for sure. So the thing is, do hurricanes occur more frequently? Well, what we're finding is in some years they do, in other years they don't, but it's not necessarily just due to the warming of the water. Sometimes it's due to like the Saharan dust that comes in, which we're actually being affected now. And so it kind of cuts down on that evaporation process and the heat that drives the hurricane. So sometimes it's other things. It's not just a matter of a warming climate. There's many other factors involved with it. So hurricane intensities and hurricane frequencies go up and down by year, depending on these other factors. Overall, though, I do think that as we have warmer waters, the chances of having more intense hurricanes increases.
Okay. What is your perspective on rapid intensification events, and are they becoming more frequent?
Well, it could be that that more people are getting in the way. I mean, and that's another thing. We're getting more $billion-plus disasters. Things cost more people are getting in the way. Hurricanes don't care. I mean, where hurricanes were coming into a swamp years ago, now there's 1 million people. So it's sort of like, a multitude of things that happen. But I think the bottom line on it all, though, is hurricanes are becoming more damaging. And that's because of all these factors you talked about.
Right. Okay, under public safety and policy, has FEMA maps and wind zone classifications improved post-disaster outcomes?
Well, I'm familiar with the FEMA flood maps, not so much any kind of wind map, but
Or wind zone, excuse me, I apologize.
Yeah, we're talking about flood zones. Flood zones, they're typically 100-year floods. You have to, elevate your home. But we're getting storms that are over 100 years in terms of their intensities. So that kind of renders a lot of those flood maps falling short because of the fact that some of these events, like the Texas flood that we just had, was a tremendous flood, and it was more than the 100-year flood. And so it was, if you built to 100 years, you'd be wiped out.
Mm-hmm. Okay, what misconceptions do homeowners have about hurricane protection?
Hurricane protection. Well, let's see. We're looking at, I would say, kind of not knowing where you're at with regard to, depending upon hearsay more than the actual information. I think that's kind of a problem. Is they're talking to their neighbors and, oh, are you gonna leave? Are you gonna go? And I'm gonna stay. We had a hurricane warning last year and it never happened. So there's this kind of complacency. I think that really is something I'm concerned about. But I'll tell you, I go in these disaster areas, and where there's lots of destruction, these people who were there and they wrote it out will not do so again. It's amazing how convincing Mother Nature can be when the disaster does happen.
All right, Tim, I got like 6 minutes left on here on Zoom. Can I do one more phone call back to you, or and then just set up another Zoom?
I think we're gonna call it quits tonight.
Okay, yeah, that's fine. And hey, I do appreciate this time tonight, and just want to say thank you so much again. And I'd like to do this with you again sometime down the road. In your closing, is there anything else you'd like to say to anyone that's getting interested into this field, storm chasing, meteorology, research, whatever? Anything you'd like to close with?
Well, sure. If you are interested in meteorology, I think that that's great, but you also have to think about how you're going to apply this. And so we want to make sure that people have like a dual major, or if you have a computer science background, that would really help out. We get people sending us resumes all the time for our company, And the people who stand out are the ones who are multidisciplinary, that they have more than one degree or in something like, or a dual major, that they have a meteorology and computer science. Those are the people who stand out, and you want to make sure that you stand out because, as you know,
Oh yeah.
a lot of people graduate with every year. So it's trying to stand out is the key.
Communication, absolutely, I agree. There's one other question I missed. I'll have to try to get it through you real quick, if that's okay. And that
Sure.
is, if you could change one national policy on hurricane mitigation, what would that be?
If I were to change one mitigation, well, it would be very controversial. I would restrict building in hurricane-prone zones, especially right near the water. I would have to have beach regulations that would have dunes in front of buildings instead of just open, flat sand beaches that give no protection. And that would be, of course, on new building. So that would not be a very popular opinion, I'm sure.
Yeah. All right. As far as flood safety, have you seen those plastic dividers that like you just like they're like shaped like an L? They're usually orange for what I've seen like on Fox News or something. Do those usually work, or is there any tools that people could probably use to help safeguard their home from a flood?
Well, if it's a flood you're talking about, and if it's only going to be a foot or two, yeah, maybe something like that will help. But if it's moving water then, and it has debris in it, then all bets are off.
Gotcha. And your thoughts, real quick, on the Guadalupe thing in Texas, closing with that.
Sure. I mean, it's extremely heart wrenching to me to see all the fatalities that have happened along that river, and it was preventable, and that's what really hurts. It was preventable. If just a matter of getting the warnings to the people and having the people react. There were ample warnings there. It's just that getting it to the people and having the people to react. That's the key. And unfortunately, it was in the middle of the night, and people were sleeping. So unless there's some sort of an alarm to wake you up, it was by the time they awoke, it was too late.
Right. Well, Tim Marshall, I appreciate your time once again this year. Thank you so much. I'm going to call you back on cell phone if that's okay with you. And
That's fine.
okay. All right, I'm going to go ahead and close out the Zoom, and I'll hit you back here in just a second.
All right.
Thank you, sir.
All right. Bye bye.
All right. Bye.